There's been a lot of talk about Juno lately, but why is Juno so important? Every time NASA launches a space mission like this, they release a series of science objectives. And today, I'm here to walk you through those. Now, first of all, you might be wondering exactly why it is that we're sending this probe to Jupiter. I mean, this isn't the first such probe we've sent, and what more could we want to know? Space missions are very difficult and, more important than anything else, very expensive. We can only send them out if there is something that we absolutely know we can't do from Earth. You can learn a lot by just looking at the light Jupiter reflects back from us in our telescopes, but for some things you really just have to get closer in to take a better look. That's what Juno has arrived to do. Other probes have flown by over the years. The Voyager probes, for example, flew by Jupiter in the late 70s, taking pictures on their way out of the solar system. The New Horizons probe passed in early 2007 when it was on its way to Pluto. And the Galileo probe actually took up orbit around Jupiter from 1995 to 2003. Its objective was to study the outer atmosphere and the gases that compose Jupiter, but then, when we were done with it, we plunged it straight into the atmosphere of Jupiter. But Galileo couldn't penetrate Jupiter's atmosphere beyond a few miles in. Now that might sound like a lot, but Jupiter is a 40,000 mile across planet. Going 5 to 10 miles in doesn't really tell you very much. That's what Juno is going to fix. Now you might be asking, how do you tell what's in the core of a planet when so little light escapes from there? To do that, we're going to be mapping Jupiter's magnetic and gravitational fields, because little changes in its gravitational and magnetic field will tell you a lot about what's going on the inside. Light from those regions does not get out, but gravitation and magnetism do. Juno will use its instruments to look straight through Jupiter's clouds. Just like the mythological Juno was able to look straight through the clouds her husband Jupiter had surrounded himself with to hide his mischief. Juno will tell us just how much water is in Jupiter's atmosphere, and that's important for a big reason. For smaller planets like Earth or Mars, they slowly lose atmosphere as it's stripped off by the harsh solar wind coming from our sun. That isn't the case with Jupiter. Jupiter's very strong gravity sticks that atmosphere to the planet, preventing it from being blown away. So Jupiter's composition is original. It is the same as it was when the solar system was first formed. By measuring the water content in Jupiter's atmosphere, Juno will be able to tell us exactly how much water was originally in the solar system versus how much of it must have come from elsewhere. That'll give us the answer to a big mystery. How did the solar system get its water? Finally, Juno will give us a good look at Jupiter's inner core, which we've never been able to do before. Some astronomers hypothesize that Jupiter started with a rocky core similar to Earth, and then slowly it got the rest of the gas by traveling around the outer solar system and trapping it gravitationally. Others hypothesize that Jupiter doesn't have a rocky inner core, and that Jupiter originally formed from the collapse of a little subregion of the large cloud that collapsed to form the Sun, making Jupiter a kind of mini-sun. By telling us what the core looks like, Juno will give us a good idea of which of these theories is correct. But these are only the primary science objectives of Juno. It's very rare for a probe like this to do only exactly what it was designed to do. Who knows what else Juno will teach us about Jupiter that we never would have seen coming? That concludes our Jupiter Week series of videos. Please check out the others if you haven't already. And before you go, please like, comment, and subscribe to our channel. We've got new videos coming out. In just the next week or two, I'm going to be doing a video breakdown of the gravitational wave discovery from LIGO, so be sure to check that out.